Hello everyone. In this video we are going to be looking at how to find a greatest common factor or a GCF. Alright, this is something that can be useful, maybe when you're factoring quadratics. First thing you're going to do is factor out a GCF. It's a little tough to do if you don't know how to find a GCF. So we're going to go ahead and take a look at this. So let me just put out some numbers here. 6 and 8. Okay. So I want to find the greatest common factor of 6 and 8. So what that means is I need to find the biggest number that I can take and it will be able to divide evenly with both 6 and 8. So it's the biggest number, so that's where the greatest comes from. Common means I can use it in all the numbers that I have, whether it be the two numbers here, 6 and 8, or even if I added another one like 10, right? 6, 8, and 10. So now I need the biggest number that 6, 8, and 10 can all be divided by, right? So that's where the common comes into. And then factor, it's a factor of those numbers, hence why we can divide with them. All right, so if you have something like 6, 8, and 10, then okay, maybe you can see right away that that's 2. Right? 6 can be divided by 2 to get 3, 8 can be divided by 2 to get 4, and 10 can be divided by 2 to get 5. Right? Nothing else is going to be bigger than 2 and be able to divide. Now the problem is, I think a lot of people get real confident, like, oh yeah, 2, I got this. But when the numbers are a little more difficult, it's a little bit harder, and then you don't really want to just sit there and try to think in your head, oh, what do they all divide by? You want to think instead, okay, how can I find this in a nice systematic way? And I'm going to show you that surefire method of finding them. All right, so let's find something a little harder than 6, 8, and 10. All right, here we have 3 different terms. And we're also including variables because that's going to be something that you probably have to do when looking at quadratics or polynomials and start factoring those out. All right, so here we have 3 different terms. So common has to be common in all 3 of them. All right, so what I want to do is I like to do this in 2 different steps. The first step is I find this greatest common factor of the coefficients in each term, the 120, the 240, and the 300, and then I worry about the variables as a second step after I finish that. So in order to do this, what we need is we need the prime factorization of 120, 240, and 300. I need to do a little factor tree and find that prime factorization. Let's go ahead and do that for each of the 3 different terms. So 120. I need to find the numbers that multiply to 120. And here, 2 numbers that multiply to 120 are 10 and 12. Now I could have did 2 and 60, right? Anything that multiplies to 120, it doesn't matter, you'll end up with the same prime factorization in the end. And then I need to keep going. 10 is not a prime number, so I need to find the factors of 10, 2 and 5. 2 is prime, 5 is prime, so I can move on to 12, which is 2 and 6. And here, 6 is not prime, so I need to go ahead and find the factorization of that, which is 2 and 3. All right, now, I'm looking at the ends of all the branches. 2, 5, 2, 2, and 3. All of those are prime numbers, so what I want to do is now write that as a list of the factors and using exponents instead of just writing them out a bunch of times at the end of branches. So here I'm going to look at each factor. I like to do smallest to biggest, so I have 2. There are 3 of those, so that would give me 2 cubed, or 2 to the 3rd power. And then I can see 3 is the next biggest, and there's only 1 of those, so it's just 3 to the 1st. I don't need to write the 1. And then 5, same thing, there's only 1 of those, so times 5. And then I'm going to go ahead and do that for the other 2 numbers, working a little quicker now that we might be used to it. So 24 times 10 is 240. 10 is 2 times 5. 24 is 3 times 8. 8 is 4 times 2. And 4 is 2 times 2. There are 4 2's, 1 3, and 1 5. 300 is 30 times 10. 30 is 6 times 5. 6 is 2 times 3. 10 is 2 times 5. So there's 2 2's, 1 3, and 2 5's. Okay? Now, that's where most of the work comes from in this. Once you have those three prime factorizations, it's a little easier to kind of finish this. Now all you're really doing is just looking for things. And what I'm looking for here is I'm looking for each common factor, so it happens in all three of those prime factorizations, to the smallest power. So what I like to do is I'll sit here and I'll say, okay, I'm finding my GCF, and that's going to equal, and then I look at the first factor, 2. I have 2 cubed, 2 to the fourth, and 2 squared. It shows up in all three of them, so it is common, but the smallest exponent on any of them is 2. So that's the one I want to take. I'm going to take the 2 squared from the purple one. Okay? And then the next factor is a 3. 3 is common in all of them. All of them have the power of 1, so that would be the smallest. And we'll go ahead and just make it blue since that one came first. And then 5. 5 again is common in all three of them. All three have a factor of 5. But the smallest exponent is the one that happens in the blue or the green factor, which is just to the power of 1. So our GCF here numerically is 2 squared times 3 times 5. All right, now I'm going to eventually multiply that out, but before I do that, we'll take a look at the variables. Now when it comes to the variables, you can do the same thing we just did to find 2 squared times 3 times 5. Think of each different letter or variable as a different factor. Find ones that show up in all three or more, however many there are here. There are 3. And take it to the smallest exponent. So for instance, we have an x cubed, an x squared, and an x to the fourth. It is common, so I know it's going to be something I want. And the smallest exponent that it shows up to is the power of 2. So since it's common, I want it. And since the smallest exponent is 2, I'm going to take it to that power. And then the same thing for y. Y is, in fact, common. It shows up in all three of them. The smallest exponent happens in the purple term, which is 1, so I'm going to take it to the first power. And then z is not common. While it does show up in the blue and purple term, it does not show up in the green term, so I'm not going to take z as part of my GCF. And it has to be common in all of the terms. All right, so that's it. That's our GCF. Now, we don't want to leave it like this. We want to simplify this. So we know 2 squared is 4 times 3 times 5, x squared y. 4 times 3 is 12 times 5, x squared y. And 12 times 5 is 60, x squared y. So that is our GCF, because if we took any of our terms, the blue, the green, or the purple, it would divide evenly with 60 x squared y. All right, take a look at the next video if you want to find out how to factor out the GCF.